This is section 9.2 on linear functions. We're going to talk about different ways to come up with solutions to a function using a function table and how to graph your solutions on a coordinate plane. So first, it says an equation such as y equals 60x is called a linear equation. A linear equation is an equation whose graph makes a line. So in the word linear, you see L-I-N-E, which makes a line. So the solution of a linear equation consists of two numbers, one for each variable, that make the equation true. So there's an x value and a y value that we can substitute into the equation and it would be true. A linear function is a function in which the graph of the solutions forms a straight line. So if your points do not lie in a line, you probably made a mistake somewhere, and double check your signs or double check on the calculator to make sure you didn't make a mistake in a calculation. One way to find the solutions is to make a function table. A function table shows the values for x and y and the function rule. So that's what you see down here. We need to find four solutions of the equation y equals 7 times x and write these solutions as four ordered pairs. So first of all, you need to pick the four x values that you want to use. So that's your choice. So I'm going to start with 0. If I pick x as 0, it's going to look like y equals 7 times 0. And we know that 7 times 0 is 0. So my first ordered pair would be at the origin, 0, 0. Now if I choose 1, it's going to look like y equals 7 times 1. And 7 times 1 gives a y value of 7. So the second ordered pair would be 1, 7. You can also choose negative values, like I'll choose negative 2. Y equals 7 times negative 2. And that's negative 14. So you get the solution of negative 2 comma negative 14. And say I pick 5. So y equals 7 times 5, which is 35. So my ordered pair is 5, 35. So again, you pick any four x values to start with, put it into the equation for x to get your y values that match up with them. So if I were to graph these four ordered pairs, they should be in a straight line. All right, so let's now look at a real life situation problem. So games cost $8 to download onto a cell phone. Ringtones cost $1. Find four solutions of the equation 8x plus y equals 20 in terms of the numbers of games, which is the x, and ringtones, which is y. Darcy can buy with $20, and explain each solution. So I need to think in my head, what values can I substitute for x and y into the equation to make 20? What makes this true? So let's think of a couple options. If x was 0, 8 times 0 is 0, so that means you have to have the y value of 20 for this to be true. So my ordered pair, x was 0 and y was 20. So remember, an ordered pair is x comma y. So this means the x was the number of games. So you have 0 games, but you bought 20 ringtones. Okay. Another one, if 8 is 8 times 1 for x, plus some number has to be equal to 20. So 8 times 1 is 8. I have to add 12. To make 20. So my ordered pair is 1 comma 12. And that means we bought 1 game and 12 ringtones. Okay, another solution, if I had x as 2, 8 times 2 is 16, so I need to add 4 here to make 20. So my next ordered pair would be 2 comma 4, which means you bought 2 games and 4 ringtones. Now I need one more solution. So let's go with the pattern here. Let's try 3. So if x was 3, I know that 8 times 3 is 24. So to make 20, this y value has to be -4. So my ordered pair would be 3, -4. But you need to think of the context of the problem. That means I bought 3 games and -4 ringtones. So that is unreasonable because you can't have negative amount of ringtones. So this one is not true. So really there's only 3 real solutions to this problem. All right, so that we can talk about another way to graph a function by finding the x and y intercept. So the x-coordinate of the point at which the graph crosses the x-axis is the x-intercept. So right here is your x-axis, and this point right here is your x-intercept. That's where it crosses x. The y-coordinate of the point at which the graph crosses the y-intercept, or the y-axis, is the y-intercept. So here's my y-axis, and where it crosses is right there. So that's my y-intercept. So since 2 points determine a straight line, a simple method of graphing a linear function is to find the points where the graph crosses the x and the y and then connect them. So we're going to look at the first example. Graph -2x plus y equals 4. Find the intercepts. So if I want to find the x-intercept, you let y equal 0 and solve the equation. So -2x plus y, but y was 0, is equal to 4. So this, if we simplify it, it's -2x equals 4. Divide both sides by -2, and the x value is -2. So as an ordered pair, it looks like -2, 0, which is on the x-axis right here. Now if you want the y-intercept, you need to let x equal 0. So up in the problem you have -2. Instead of an x, substitute a 0 plus y equals 4, which this just is y equals 4. So my ordered pair for this one is 0, 4, which is 4 above the origin. Then lastly, you need to connect them with a straight line. So make sure you use a ruler. Extend it, stretch it out throughout the graph, and make sure the end has arrows because a line goes on forever. And the last part of today's lesson is talking about real life problems with the x and y intercepts. So this is after x hours of driving, there are y gallons of gas remaining in the car. For Becca's car, this situation can be represented by 1.8x plus y equals 18. Find the x and the y intercepts. So if I want the x intercept, you need to set y equal to 0. So in the problem you got 1.8x, y was 0 so it disappears, equals 18. Divide both sides by 1.8 and x equals 10. So that as an ordered pair is 10, 0. And that means that when after 10 hours her tank is empty. Next, if I want to find the y-intercept, you set x equal to 0. So you got 1.8 times 0 plus y is 18. So this part disappears. You just get y is 18. So your ordered pair is 0, 18. So this means when before she starts driving, because she didn't drive for any hours, her car has 18 gallons of gas.